The number systems are mainly classified into two types, positional number system as well as non-positional number system. For each digit, I'm going to have the position as well as weight, and that kind of number systems are known as positional number system. By using non-positional number system, I cannot able to perform any arithmetic operations effectively. Hello to all, a warm welcome to my new session on fundamentals of computers, and the chapter name here is number system. I am Revati from the Department of Computer Science, Vidhyaashram, first grade college, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to see the topic which I have discussed in my last session of this unit. So I started with classification based on computer, that is principles of operation. That means computers are classified based on the principle of operations in three types, that is hybrid computer, analog computer, digital computer, and hybrid computer. Whereas if I consider computer system based on the configuration, once again categorized into four types: microcomputer, mini computer, mainframe computer, and at the last I'm going to have supercomputer. Now, so dear student, the computers are classified into two types, once again based on the purpose, that is general purpose computer as well as application specific computers, and these are the topic I have covered in my last session. And from the examination point of view, this is also very important topic. Now, in my today's session, at the beginning, I'm going to deal with the introduction about number system. Along with that, I'm going to deal with the types of number system. So, dear student, instead of wasting time, let's see what is number system. So, dear student, if I consider any digital computers, they are capable to understand only zeros and ones. Now, what is this zeros and ones? There is nothing but the machine instruction. That means computers are able to understand only machine instructions. So, in digital computer, data and instructions are stored in the computer memory. If I consider any digital computer, all the data as well as instructions are stored in the computer memory using binary code, that is known as machine code. So it is represented in the form of zeros and ones, and it is known as binary digit. So it is known as binary digit or bits. So binary digit means what? It is 0 and 1, and it's also known as bits. So the number system uses well-defined symbol called digit. If I consider any number system that's going to use well-designed symbols known as digit, and the number systems are mainly classified into two types: positional number system as well as non-positional number system. Followed by, I'm going to have non-positional number system. So what is this non-positional number system? For this, I'm not going to have any weightage, and the best example for non-positional number systems are Roman numbers. So here for the specific numbers, I don't have any positions. For that reason, it is known as non-positional number system. So the non-positional number system consists of different symbols. So here non-positional number systems are going to include different symbols and that are used to represent numbers. For example, if I want to represent any numbers in non-positional number system, I'm going to use different symbols. So Roman numbers are the example for non-positional number system. Now think that if I want to represent 1, then I'm going to use capital letter I. Suppose if I want to represent 5, then I'm going to use capital letter V. And if I want to represent 10, I'm going to use capital letter X and it's going to continue. So I'm going to use the symbol to represent the digit and that is known as non-positional number system. And by using non-positional number system, I cannot able to perform any arithmetic operations effectively. So this number system cannot be used effectively to perform arithmetic operations. Now, I'm going to have second type of number system that is known as positional number system. For each digit, I'm going to have the position as well as weight, and that kind of number systems are known as positional number system. So dear student, here positional number systems are categorized into 4 different types, that is decimal number system, binary number system, octal number system as well as hexadecimal number system. Anyway, we are going to study what is decimal number system, what is binary number system as well as what is octal number system and hexadecimal number system in detail. Now, I'm going to have the total number of digits represented in any number system are known as base or radix. For example, dear student, I'm going to write 867 and if I write, so what is this? This is nothing but the digit. That means this is nothing but the decimal number system and it is going to represent the range of numbers I can able to use here. So what is my range? It is 10. That means I can able to use the number 0 to 9 in my decimal number system. So here the total number of digit. So 0 to 9, it is 10. So what is the total number of digit I can able to use here? That is 10. And this is itself known as base or radix. So here the total number of digits present in any number system is known as base or radix. And every number is represented by a base of x. So it is base of x which represents x digit. For example, think that I'm going to have 367 and if I write 8, this is nothing but octal numbers and it can able to have 8 number. And what is the range here? That is 0 to 7. So here 8 is nothing but the x. X is nothing but the base or radix. The base is written after the number as subscript. So here to represent base, always I'm going to use subscript, that is x. So here I have 360 and it is decimal number. To determine the quantity that the number represents, the numbers are multiplied by the integer power. So here to determine the quantity, what I'm going to do? I'm going to multiply that number by integer power, that is x. Depends on the position it is located, and then find the sum of the weighted digit. So at the end, I'm going to find the sum of the weighted digit. So this is the example I'm going to have here. So here I have the number 512.45 and this is my decimal number. I want to represent this number in the form of decimal. Now see, I'm going to write the position here. It is present at the position 0, 1 and 2. It is -1 and it is -2. And I'm going to multiply those weights by the corresponding values, and at the end I'm going to add all these values together. Now I'm going to have decimal number systems. That means positional number systems are classified into 4 different types: decimal, octal, binary and hexadecimal number. And at the beginning, I'm going to have hexadecimal number. So this is the most widely used number system. The decimal number system consists of 10 digit. There's nothing but 0 to 9. So it has 10 digit. Hence the base or radix here is 10, and it is mainly used to represent any numerical value. And I'm going to have the example here. So dear student, please remember here that in decimal number system, to represent numbers, I can able to consider 0 to 9 and I want to write the base, that is 10. So here I am having 140 base 10, 555 base 10, 3200 base 10. Now see, I'm going to have the simple example here. So this is the example for decimal number system. So I'm going to have 542.76. So dear student, please remember here that I'm going to have the integral part as well as fractional part. And to my integral part, whatever the position I'm going to specify, that is in the form of positive numbers. And if I consider fractional part, whatever the position I'm going to specify, that is in the form of negative numbers. So here what I will do, I'm going to split this number into 2 parts, fractional as well as integral. Now see, these are my integral part and these are my fractional part. And while positioning, I'm going to start from 0, 1 and 2. So these are my units. So it is decimal number. For that reason, 10 to the power 0, 10 to the power 1, 10 to the power 2. At the same time, what I will do, I'm going to write the numbers with their respective place. Now, if I consider fractional part, I'm going to start with the negative power. Okay, now what I will do, I'm going to multiply all these numbers. For example, if I consider 10 to the power 0, what is the value? By the mathematical property, I'm going to get the value 1. Now, 10 to the power 1, it is 10. 10 to the power 2, 10 into 10, it is 100. And here it is 10. And I'm going to multiply. So, 5 into 100, it is 500. 10 into 4, it is 40. And 1 into 2, it is 2. Now, 10 to the power -1, that is nothing but inverse. I want to find the inverse of this. Then I'm going to get 0.71, and at the same time I want to find the inverse of that. I'm going to get the value 0.06. and I'm going to add all these values so I can able to get this result. Now I'm going to have my next type, that is binary numbers. So digital computer represents all kind of data and information in the form of binary system. If I consider computer system, all the data are represented in the form of binary numbers, that is nothing but zeros and ones, and computers are able to understand only zeros and ones. So a binary number system consists of two digits, that is 0 and 1. So dear student, 0 is nothing but always low voltage, whereas 1 is nothing but always high voltage, and its base is 2. That means to represent binary numbers, I'm going to use the base 2. And each digit bit in binary number system can be 0 and 1. That means if I consider binary number system, the digits are in the form of zeros and ones, and the positions are expressed in terms of power of 2. So the position values are expressed in power of 2. So this is the example for binary number system, that is 1011 of 2. So what is this? These are the binary numbers. Now consider the example here which can be represented equivalent value as. Let me to consider the example here 11011.10 of 2. So what I will do, I'm going to write the position. This is present at the position 1, this is second position, this is third position, and this one fourth position. Here it is -1, here it is -2. See here, I'm going to write the position, that is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and for my fractional part 2 to the power -1, 2 to the power -2. Now what I'm going to do, I'm going to find the power of all the positions. At the same time, I'm going to multiply the power with the digit, and whatever the value I'm going to write, I'll write as it is, and at the end I'm going to add all the numbers together. And for my fractional part, I'm going to find the inverse of that. So this is the way I can able to find the binary number, or I can able to represent the binary numbers. Now the leftmost bit 1 is highest order. So if I consider this one, it's going to have highest order. For that it is called most significant bit, and the rightmost bit 0 is the lower power bit, and it is called least significant bit, or LSB. Followed by, I'm going to have octal number. So what is this octal number? That is nothing but the base 8. So the octal number system has digits starting from 0 to 7. If I consider any octal number, the digits are represented in the range 0 to 7, and the base here is 8, and the positions are expressed in power of 8, and any digit in the system is always less than 8. It's not less than or equal to 8. It's always less than 8. So what's the range? That is 0 to 7, and this is the example I'm going to have. So here, if I consider this example, it is not octal number. Why it is not octal number? Because 8 does not comes under octal number representation. Now, I'm going to have the example here. So, this is my number. Now I want to convert this into octal. Now, what is the power? It is 8. So 8 to the power 0, 1, 2, minus 1, minus 2. And I'm going to perform multiplication with respect to the positions. Then I'm going to add all the values together. And if I consider fractional part, I'm going to find the inverse of that. So 5 into 1 by 8, and whatever the answer I'm going to get, that is the value. So this is the way I can able to use octal number system. Now I'm going to have my last type, that is hexadecimal number system. So here hexadecimal number system consists of 16 digit. That means it's going to use 0 to 9 digit, that is decimal digit. Along with that, 10 is represented as A, 11, B, 12, C, 13, D, 14, E, and 15, F. Okay, then what's the range of hexadecimal digit? That is 0 to 15. So here the letter A to F represent decimal number from 10 to 15. So here A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So for that reason, the base here is 16, and these are the example for hexadecimal number. Now, I'm going to have the example here. So, here what I will do, I'm going to write the power of that. 0, 1, and 2. And what I will do, I'm going to find the power of each digit, and I'm going to multiply with the digit, and I'm going to add all the digit in order to get the final output. So here I'm going to have the number system, and if I consider binary number system, what is the base? It is 2, and I'm going to have 0 and 1. And if I consider octal, it is 8. So 0, 1, 2, 3, 4, 5, 6 and 7. And if I consider decimal, it is 10. So 0 to 9. And if I consider hexadecimal, I'm going to have 0 to 15. For that 0 to 9. After 10, it is A, B, C, D, E and F. So this is the way I can able to represent positional number system. So dear student, in my today's session, I started with what is number system. Along with that, I have covered the two type of number system, that is positional and non-positional number system. So example for non-positional number system, that is Roman numbers, whereas positional number system, that is binary number system, hexadecimal number system, decimal number system and octal number system. And dear student, in my next session, I am going to deal with number system conversion. Let's meet in the next session with more information about number system conversion. Until that, keep watching and keep learning. Thank you.